everybody. All right, I hope you enjoyed lunch. We are going to kick things back off, so hopefully the people at the other side can hear me. Next, we have Rob Frohnapfel from Comcast, who is going to talk about turning cloud metrics into results. Please welcome Rob to the stage.
Thank you very much. Good afternoon, everyone. My name is Rob. I work for Comcast. Our team is responsible for application platform delivery for Comcast product and development teams. So today we would like to talk to you about how we've been able to take time series data and awesome open source tools like those developed by InfluxData and deliver some really fantastic results. So along the way, I'm also going to highlight the story of how a group of 20-year IT veterans have transformed themselves into innovators that are writing code and automating everything. So before I start, I'd like to get a read of the audience. How many folks in the room come from what you may call a traditional enterprise organization or a large company? Don't be shy. Okay, that's a good amount of hands. Well, hopefully what I have to share today is going to be very interesting to you. So before I jump into that, I would like to highlight the fact that I think most of you, or I assume most of you, know what Comcast does, what our products and services are, things like that. But what you may not know is that we are deeply committed to open source technology and community. So besides being members of the foundations that you see up here on the screen, we are also active contributors to the community. So I think Comcast's internet public GitHub repo has about 195 repos within that project. We also contribute to other projects out there. So some notable ones would be OpenStack. Comcast was one of the largest contributors of the IPv6 driver in a prior version of OpenStack. So beyond those things, we also have a very thriving open source practice within Comcast. So this is a group of folks that are out there promoting within our product and dev teams the importance of community and contribution. And then a few other ways that we engage with open source community. Our team especially spends a lot of time with the different foundations and the different software vendors and companies out there like Influx to help drive the roadmap of their products so that the features that come out are things that are attractive to large enterprise corporations. And then finally, we also do spend a good bit of time promoting the foundations through things like public speaking engagements, as well as through marketing work group contributions. So that was just a quick bit on Comcast. So let's jump into our story here today. Our team has been shaped by the industry, by technology evolution, and by the requirements of our product and dev teams. So over the years, about 15 years ago actually, a lot of us were working on physical server hardware. We were Microsoft and Linux administrators at Comcast. Over time, we moved into virtualization. We started using VMware, ultimately delivering self-service for VMware. So that was our first iteration of infrastructure as a service at Comcast. That resulted in a pretty sizable VMware infrastructure, which I'll get into with you here shortly. Over time, we delivered Cloud Foundry platform as a service for Comcast. So Cloud Foundry has had an exponential adoption within our product and dev teams, mostly because of all the great benefits that it has to offer. Things like multi-cloud portability, auto healing, auto scaling, things of that nature. So we continue to really drive Cloud Foundry, both the pivotal and the open source versions of that platform. We're also working on container orchestration, so that's an active project we have underway now. We see containers and Kubernetes as a means to fill the gap between IaaS and PaaS. Our methodology is that our developers should not have to worry about managing infrastructure, so platforms like Kubernetes really help to remove the friction and the heavy lifting from our development teams. And then we're starting to dabble in function as a service. We see that as a logical progression. We're doing some R&D in that space, and we're excited about that in the coming months. So something else we realized as we evolved through this progression of platforms is that as you move from the ground to the clouds, developer velocity increases significantly. A lot of that has to do with removing the friction and the heavy lifting that I described to you. We also realized that, that the ability to run in a multi-cloud configuration and move your workloads where you need them, whether that be public or private cloud, is a huge game changer for our development teams. So put your workloads where you need them based on things like proximity to other services or based on cost. So there's a bit of history about our team, our services, and what we've been doing the past 15 or so years. So let's move into our challenges. We'll take a walk back in time about 3 or 4 years. 2014, our team was managing platforms that had hundreds of unique applications running on them. We had at least 1,000 application developers. And we had a huge number of VMware virtual machines, VM hosts, as well as a ton of enterprise storage. So by enterprise storage, I'm speaking about traditional SAN-based storage arrays by companies like EMC and Hitachi. Our goals back then were really to transform our mindsets and transform how we deliver infrastructure, how we manage infrastructure, and how our developers bring their products to market. So I talked about infrastructure heavy lifting. Our developers were doing a ton of that back in the day. So to get a virtual machine, they could go do that in a self-service fashion, click a few buttons, get the VM, but they still had to do things like request load balancing, request firewall rules, patch operating systems, all those things. So we wanted to remove that friction from them. We also wanted to consolidate our tooling. So not only for ourselves, well, pretty much for ourselves on that item. We wanted to provide transparency not only for ourselves, meaning like how can we have a better view of the environment, how it's performing, but we also wanted to provide that transparency to our customers, to our product teams. They should be able to see how are the environments performing. We wanted to drive efficiencies and identify opportunities. And then ultimately, we also wanted to provide some basic application metrics. As folks deploy onto our infrastructure, we felt that they should have some basic metrics available to them. So right around that time is one of the clever engineers on our team was looking for a way to monitor Cloud Foundry and provide metrics around the Cloud Foundry stack. And that was our first introduction to InfluxDB and Grafana. So he was playing around with some visualization and pulling in that time series data. And he sent a link that looks much like this out to our team. And immediately upon looking at this, it was really like a light bulb moment for us. So he had written a little bit of code, tapped into an API, pulled data out and pushed it into Influx, and he was able to draw a picture that looks much like this. So immediately we thought to ourselves, well, why couldn't we do this for everything that we support out there? You know, we've got the VMware, the storage, cloud platforms like CF. So our team really focused on the idea of creating a product out of all of those metrics that we could use to kind of suit the goals that I described to you here. So the team started to all kind of ramp up on writing a little bit of code. Again, I remind you, these are traditional sysadmins. These are guys that were typically Windows or Linux administrators. They started dabbling in Python and Golang. They started to learn some DevOps tools, such as Concourse and Ansible. And it wasn't long before they started really delivering something tangible. So I described to you that we had all these things. We had all this infrastructure, all these systems. Our team started to write a little bit of code, and we had just discovered great things like InfluxDB, Grafana, and Telegraph. Shortly thereafter, we were able to deliver consolidated metrics dashboards that pretty much summarized our entire environment. So this was really important to us. You know, we began to use this stuff for performance and capacity management. By using these tools, we were able to target exactly the things that we were looking for. So back in the day, capacity management for us was a very manual and reactive process. It meant folks would have to go log into lots of different systems, pull data into spreadsheets, aggregate that together. And we could use that basically as a single point in time snapshot that we could use that day. Now the problem with that is that we had to rinse and repeat that over and over again throughout the year. So anytime we wanted to buy something, anytime we wanted to forecast, budget, et cetera, folks had to go do this manual process. Well, now that we had pulled all this data into one place, it was really simple to do capacity management. And in a lot of cases, I could do that myself within a matter of minutes. Performance management really was not happening at all. Either we were too busy, we didn't have the data, or it took too much time to go collect all that data and pull it together. So that was another very important piece of this puzzle here, where we could now have a very quick snapshot at a very high level of aggregated performance across our environment. So let me jump into that. And for the next few minutes on this slide, my focus is going to be that metrics equate to balance, and balance equates to efficiency. So let's start with a VMware-based example here. How many folks out there have large VMware environments within their companies? Terrific. How many of you think that the VMware teams really know what their environments are doing? Nobody, okay. We didn't know what our environment was doing. And this is a great example. So once we had the aggregated data, it was immediately obvious that there was a major problem here. So what you're looking at is two different regions within our infrastructure. Each line represents a cluster within that region, and each cluster could have up to 32 nodes running within it. And each node could have up to 30 VMs running on it. So there's a ton of infrastructure depicted here. And really the important thing to note is those spikes. You see that clusters are spiking at 100% CPU utilization for sustained periods of time. So we knew that meant there were problems. We knew that our customers were feeling pain. And actually they had been telling us they were feeling pain, but we never really had the data to back that up. You know, we heard a lot of anecdotal remarks, but never really had the data to back it up. So once we saw this, it was like, holy crap, something needs to be done immediately. We began to focus on taking the data and making some decisions on how to spread that workload, how to balance that workload across clusters. So that was something at the time that was not available within VMware's product suite. They could do vMotions within clusters, but not cross-cluster. So we spent a lot of manual time. We did that rebalancing. Shortly thereafter, things started to look like this. So immediately, a few things happened. One, customers started to thank us. Two, vMotions in the environment, which we had measured at one point at around 100,000 vMotions within one vCenter in 1 month. That dropped down to about 500 vMotions within that vCenter within a month. So I often wondered to myself, 100,000 vMotions, these things are thrashing. How are they even still running? So that was a really big deal. In addition, this offered us cost deferral, because our old methodology when things started to get bad was to buy new stuff and then let it fill up, and then buy new stuff and let it fill up, and that was kind of how we operated in a reactive state. Some other interesting things here, kind of to back up the point I just made. If you look on the screen, the lines that are at the bottom of the graphs, those are mostly the new clusters that had just been provisioned. The stuff that's really spiky all over the place, that's the stuff that was full, basically. So by going through the manual exercise, it pulled all those lines together, balance across the environment, things started working better for everyone. So that was the first example, VMware performance balancing. How many of you out there have a lot of enterprise storage within your organizations? I keep seeing the same hands. That's awesome. How many of you think that the storage folks know what their storage is doing? Less than the VMs? Okay. We had no idea what our storage was doing. And I don't have slides for this. I'll just speak to it, but it's the same concept, the same theme. So we found two really distinct use cases for storage balancing. One was the storage guys are always saying, we need to buy more, we need to buy more. To them, the storage arrays looked like they were full, or they had hit the capacity threshold that we had predefined for them. When in reality, we had a ton of stranded storage within VMware data stores. So by balancing the storage throughout the VMware data stores, we identified tons of storage that we could go clean up and reclaim. Along those same lines, we had a severe lack of balance across storage arrays themselves. So again, these are SAN fiber channel-based storage arrays. We would buy one, fill it up, buy another, fill it up. Once we visualized that and we saw that condition, not only did we have stranded capacity, but we also had performance issues. Some of the arrays were were cranking so hard that they couldn't take another I/O, while others were barely doing anything, but all the storage was consumed. So along those same lines, we spent some time manually rebalancing things, ultimately writing some automation that could help do that for us, and then writing some process so the folks provisioning storage, could follow best practices so that they could provision things more efficiently. So these were really big deals, and these were really big wins. Again, this is all stuff we kind of did in the beginning as we first got started with InfluxDB and time series data. Let's talk a little bit about tenant reporting. Anyone out there have multi-tenant private cloud platforms within your infrastructure? Very good. You probably know my question already. So how many of you think that folks managing that stuff know who's using it, how much they're using, how much waste there is, and how much that all costs? We did not. We definitely did not. So we started taking that time series data, marrying it up with things like our business entity information or our CMDB, and now we could visualize who's using what and how much they're using. So this is just a simple example of Cloud Foundry and the usage there, and that's wrapping up to the business entity. Here's another example. This one is VMware-based stuff. This one is really interesting because not only can we see who's using it, but we can see how much waste there is. And we can take that and marry that together with our TCO model, and we can put a cost to it. So a couple interesting things about this. The first is, prior to this reporting, we would go to finance and tell them we need to purchase capacity, and we had no idea who was using the capacity. So it looked like it was us, essentially. After this, we could go say we need to buy capacity. We could give them this link, and they can see that it's actual Comcast product teams consuming it. So that greatly accelerated our ability to procure capacity. In addition to that, publishing waste information and cost information is really inspirational to the teams consuming it because they don't want you shaming them in public. So that gave back a lot of stuff to the environment and inspired people to give back those wasted resources. So that was my third very kind of basic example of how we got started with time series data, found some awesome opportunities, took action, delivered results. Let's step back to this slide here and talk a bit about monitoring. So as we matured, we started finding challenges with traditional monitoring solutions. So we were not new to monitoring. We probably owned every single tool that commercially is available for monitoring. We were really good at using that stuff. We could install agents, configure SNMP. It was part of our deployment best practices, our deployment process. But it really was only applicable to that traditional infrastructure, physical servers, IaaS. As you moved up the stack, things started to get a lot more difficult. So there was a handful of problems associated with monitoring and telemetry across modern platforms like Kubernetes or Cloud Foundry. So one of those problems was very ephemeral workloads. There were things spinning up, there were things shutting down. So those old monitoring solutions in a lot of cases really relied on static things out there within your infrastructure. Containers and functions spin up and down all the time, a lot of elasticity there. There's nothing static about that. So that was the first. Sporadic workloads based on these things spinning up and down all over the place also made it very difficult to use a traditional approach like a pull-based approach within a monitoring solution. And then we had such a variety of systems that we needed to collect data from. We needed a really simple interface to be able to push that data in. So our approach kind of changed here from the traditional pull approach and the worldview approach that a lot of the older traditional monitoring solutions had. We started to move towards more of a push approach, kind of the don't call me, I'll call you approach. And that's when we really started to refine our monitoring and telemetry strategy. So we found the perfect centerpieces for our strategy: InfluxDB and capacitor. So what I'd like to do is just kind of talk you through the flow of this strategy. This picture is specific to Cloud Foundry, but the same approach is taken with Kubernetes and other modern platforms. So we've got InfluxDB and capacitor at the heart of everything. Capacitor is enriching our data and helping us process alerting. And then we've got a ton of feeds from all different directions pushing data into that solution. So we've got traditional VMware vRealize Operations Manager is pushing in VM and infrastructure metrics. We have Nagios tied into the Cloud Foundry JMX bridge to push in all the Cloud Foundry platform metrics. We do a ton of work with Telegraph. We love Telegraph, and we've actually written a few enhancements for that and open source those. I'll talk about those more in a minute. But Telegraph is basically collecting application metrics as well as some of our own platform metrics and pushing them into Influx. And then we're using some Riemann processing to process logs and aggregate logs and push that into Influx. So that's the feeds. Kubernetes Heapster could be drawn in that picture if you want to apply this to Kubernetes. So that's the feeds. As far as visualizing, if you look across the top, we use status.io. That provides us with a means to publish to our customers, here's maintenance we're going to be working on, here's information about a problem in the environment. We're really big on Slack. We've got a very thriving Slack community, especially related to Cloud Foundry. So we push a lot of alerting into Slack, again, about problems, about maintenance, things like that. We have Alerta, again, processing a lot of our alerting. And then Grafana, you've seen a lot of screenshots from Grafana here. We've had a lot of success over the years with Grafana as well for visualizing and publishing our metrics. So there's our strategy, and you know, over time we've evolved, and again, this took a few years for us to come up with. The thing we really like about this approach is that it's not a single monolithic solution. It is a collective of different tooling that are really, really good at the things they do. And it enables us at any time to take a component out and slide a new one in as the next greatest thing comes out. It also lets us to retire old things, you know, as they start to fall off. So it's a very modular approach. So I've talked about some success stories, some results we achieved in the early days. I've talked about our strategy that is now working very well for us within our Cloud Foundry and Kubernetes infrastructures. I want to talk about a few concepts that kind of helped us lead up to these things and drive some successful results. So the first concept is the DevOps mindset. Now, for you folks out there working in startups or small software shops, this is probably just plain second nature to you. But for you folks working in enterprise organizations, you probably understand that this is a really hard concept and a really difficult thing to kind of ingrain in people. So how did we ingrain this in our folks who used to be sysadmins and get them to start writing code and automating everything? I just wanted to give you a few examples of that. So first off, the team just naturally inspires each other, as I'm sure your teams do. So if one person does something awesome, it inspires everybody else to say, hey, I want to do something awesome. So they start working hard towards that. Performance goals, you know, your yearly HR goals that you put in whatever system it is that you use. We started putting goals in to take your scripting skills and ramp that up into a software development platform like Python or Golang. We started to put goals in for things like create automation mechanisms. And slowly over time, the team started to really embrace that stuff and really do that stuff. So this was really, really important to us and helped us really achieve a lot of the stuff I've shared so far. Equally important is partnering with your stakeholders, partnering with your business. So I'll give you some examples of how we do that. I mentioned Slack. Our Cloud Foundry Slack channel has over 1,100 members. So these are developers that are consuming the platform and deploying applications on it. What's really cool about this community has built itself and over time has grown to the point where any given time you look within the channel, you'll see people asking questions on how to use the platform. And it's not our team answering the questions, it's other customers. So that was a really powerful concept, building community. Transparency, I talked to you about sharing your metrics. Open that stuff up. It helps to build trust with your stakeholders. Open forums. We host a monthly open forum with our Cloud Foundry community. And we start that meeting not by pushing our agenda, but by asking our customers, how are things working? What's working for you? What's not working for you? And then we're very open and honest about when we have an outage. Here's what happened. Here's what we're going to do to make sure it doesn't happen again. And then finally, a concept that I really like is run it like a business. So this gets lost a lot within large companies, I think. If you were running your own business, what would you be doing? You would be out there soliciting feedback from your customers, taking that feedback, putting that into your roadmap, and your backlog would essentially be built based on the requirements of your customers. This isn't 2005. You can't be an IT shop and sit in the basement and not talk to anybody. So that's really driven a lot of success for us as well. So let me summarize the results of all these efforts that I've described to you here. So today we have over 1,000 unique applications running on our platforms. Some of the most critical customer-facing applications that you may use in your home if you're a Comcast customer. We have over 2,000 app developers actively developing on our platforms. Our team individually is not really in the VMware game anymore. We've kind of handed that off to our SRE team. But that environment now has 80,000 virtual machines. And then there's a ton of VMware hosts. Cloud Foundry, I mentioned exponential adoption. We've got close to 20,000 Cloud Foundry application instances running out there across 14 foundations in both the private and the public cloud. And then approximately 80 petabytes of enterprise storage. So the results, major transformation, mindset, how we manage infrastructure, how we deliver products. We removed a lot of the infrastructure heavy lifting that I described, but I have work in progress here because really that's always a work in progress. So if you're running platforms, you need to continually look for where are the bottlenecks that your customers have? What can I do to remove those bottlenecks? We consolidated our tooling. We have full transparency throughout the environment for both ourselves as well as for all of our customers. They can go see how everything's running at any given time. We exercised a ton of opportunities and drove a ton of efficiencies, including a ton of cost savings. And finally, application metrics are available the minute an application is born within one of our platforms. So by using the strategy that I showed you earlier, if you deploy an app in our Cloud Foundry or in our Kubernetes infrastructure, within minutes, you now have application metrics available to you. So those are our results. So what's our experience been with InfluxData so far? Hopefully the stories I've shared here and the examples I've given have demonstrated that we give Influx a big thumbs up. And when I was talking to the team about this presentation and what we wanted to share, and I asked what are some of the most valuable things that you think Influx has helped us deliver, Besides the results I showed, one of our senior engineers, Tim Leung, he just made this statement: it just works. And that really is the bottom line for us. It just works. So as I wrap things up, I just wanted to share a few open source contributions for those of you out there using Cloud Foundry. You may be interested. 2 Telegraph enhancements written by Sergey Matuchkin, who is here with us today. Sergey is also part of the brain trust that came up with the whole monitoring telemetry strategy. So we've got a Cloud Foundry Telegraph build pack, which lets our application folks out there quickly and easily deploy Telegraph and a Telegraph config against their app. And then we've also got a Telegraph release for Bosch, which allows Bosch to manage Telegraph in a very self-healing fashion. And that was pretty much everything I wanted to share with you. Thank you so much, Influx, for letting us share our story here today. And I appreciate your time. Thank you very much. Sure. And Sergey will join me to answer any questions you may have.
I got one.
Sure.
What are you doing around AWS instrumentation?
We deploy platforms like Cloud Foundry and Kubernetes on top of AWS, and we manage them as we would within our own private cloud environments. Same metrics, all the same stuff. Yeah, and the beauty of that is, again, folks can shift their workloads private, public, or maybe one day to Azure, GCP. Yeah, we're not big on vendor lock-in or cloud lock-in, so that's kind of the approach there. Thank you.
I just wanted to know clarification on what you might use for buffering in your Telegraph pipeline in terms of the messages coming in. Are they buffered in some persistent store for a period of time, or how are you managing that?
Sergey, you may want to take a swag at that.
Yeah, I'll try to answer this question. We don't do much with buffering. We are trying to minimize distance between emitting metric and consuming. But what we found is very useful is that Telegraph buffered itself. And in many cases, we are passing our metrics, even if it's in a stream ready to consume by Influx, we are still passing through Telegraph. Example is a hipster. So Kubernetes hipster can stream data, so it has a sync for InfluxDB, but we're still passing it through Telegraph. So what is happening if Influx is too busy, if there is a network issue or anything else, then Telegraph is still buffering it for quite significant time. I don't know how long, but at least if we need to do some upgrade and quick restart, that takes 5-10 minutes, the data is backfilled. So we don't need to do anything for that. Now, we have some other streams like processing log data, parsing, extracting metrics, and feeding to InfluxDB, and we are using other tools for that, like Riemann, for example, and we are thinking to use more other general purpose streaming processors as well. But we don't do it at this point.
Can you talk a little bit about how many actionable alerts you get in any given day and how you kind of manage that kind of support load?
Actionable alerts.
So like alert outages to customers, level 1 support. What kind of load do you guys manage?
Those are really good questions. You want to take a swag at that?
Yeah, this is a good and interesting question, and we are operating at any point of time. We know that there is an outage somewhere, and we are ready for that. It is not necessarily a deal breaker for us. So in a Cloud Foundry world, and also we are trying to bring the same to Kubernetes. We are using Bosch to manage Cloud Foundry, And Bosch is an awesome infrastructure provisioning, application provisioning tools on top of infrastructure that also provides self-healing capabilities, right? So we do have alerts sometimes, and often they clear themselves. So how actionable they are half actionable because we need to know about them, but we are not necessarily do anything with that. So from a pure number perspective, on a platform as a service, I'd say it's a couple of days, not more than that, that really needs our attention. Because the way how we design our applications, we assume at any point of time something will break, but it should not necessarily to affect the customers and our users.
Yeah, that was a great answer. I'll build on that a little bit. So with Cloud Foundry, we took the methodology and we pushed this with all of our customers. Deploy in multiple sites. Use things like GSLB to be able to move your workload back and forth. So that's how it is with CF. That's how we're moving into with Kubernetes. Since we got away from VMware and storage and kind of the more traditional stuff, the world has gotten a whole lot quieter for us because of these approaches and the things Sergey said. So it's extremely rare that I get an after-hours call ever. And when there is an outage, like something crashes in one site, it typically very seamlessly fails over to another site. Yeah. Good question.
Yeah, similar question, I guess, but how real time? Like, what is the kind of latency that you're looking at? I mean, you were mentioning days for alerts where things can kind of self-heal. Do you have anything that's near real time that you want to keep a track of?
Well, the data collected for the applications is close to real time, right? So depends on metrics that we collect. It's somewhere 30 seconds to a minute, and that data is available to our customers, to our users of our platform, which are DevOps teams in our developers. So that is pretty close to real time. But for capacity analysis and capacity planning, we are doing different kind of measurement where a day is not important. So yes, to answering to your question, for important metrics that are important for our users to know right away, or for something that affects platform stability right now, we are trying to deliver these metrics in a close to real time. But for other, we can wait.
Thank you. Awesome. Thank you so much.